4.5 Quantitative Data Analysis Techniques. Data preparation. So before you actually begin putting things into graphs or looking at results and inferring things from it, you need to prepare your data. So this is usually broken down into range, rank order distribution, simple frequency distribution, and grouped frequency distribution. The key point here is that you're just preparing the data for later use. You're not actually doing anything with it yet. So you can see a definition by Adams from 2010 on the screen. So that definition is the distance in numerical value from the highest to the lowest value collected. That is the definition of range. So yeah, range is the difference between the highest value and the lowest value in a set of data. Therefore, to calculate the range, you subtract the lowest value from the highest value, giving you the difference between the two. In figure 1, you can see a clear example of how this is done. This example shows fitness data from British gymnasts, and the ranges of each of these sets of data can be clearly distinguished by the highlighted yellow cells. In Excel, to work out the range, you have to manually type the calculation. You type equals max, click on the cell with the maximum value, and then minus min, and then you click on the cell with the minimum value. Excel will then calculate the range for you. Of course, you can go through each set of data and manually calculate the range yourself if you wish to do so. The range is a really relevant calculation if you wish to establish how much of a difference there is between your data. A smaller range would imply that there isn't much relationship between the values, as they aren't that close together. For example, if you had a range of 100, your smallest value might be 1 and your highest could be 101, meaning there is a big difference between those values. In contrast to this, a range of 2 would mean there's much less of a difference and your values are much closer to each other or more closely related. However, looking blankly at just the range value doesn't allow you to determine whether the reason for the large range is because of an outlying value or anomaly. You have to go back through the data to determine this. Range is perhaps used most commonly in test scores, so for example fitness tests like the one we've done here, to determine if the whole group is of a similar level or if there is a big difference between people's abilities. Rank order distribution. So rank order distribution is when you put your values in order from highest to lowest value. So again, we've got a cited definition, and that definition is placing your data into an ordered list from the lowest to the highest in a single column, ensuring you include all the scores. You can achieve rank order distribution on Excel by highlighting the column you wish to put into rank order, and then placing the highest to lowest filter on it. Alternatively, and depending on what data you are presenting, you can filter them from lowest to highest. An example of this is shown in Figure 2 and Figure 3. Figure 2 shows the raw data of chest throw scores by GB gymnasts. You can see that all of the values are in random order at this stage. In Figure 3, you can see that the values have been put into rank order. On the left, there is the rank from 1 to 14, which is the amount of values there are. In coordination with this on the right are the scores / values with the highest at the top, ranked at number 1, and the lowest at the bottom, ranked at 14. They are ranked from highest to lowest, as the larger the chest throw, the better, so the largest value is the best value. Not all data will be ranked highest to lowest, as for some sets of data the smallest / lowest score is the best score. For example, if you were testing sprint times, the lowest value would rank the highest, as this is the quickest time. To put it simply, the purpose of rank order distribution is to rank the data from best to worst or highest to lowest. Simple frequency distribution. Simple frequency distribution is used when the number of participants is greater than 20 and when the range is less than or equal to 20. To achieve this, you display the data in a table with 2 columns, one for the raw data and one for the frequencies. You note each number that occurs in the data and then tally how many there are of each of those values. So the number 2 might occur 5 times in your data. Here you would write a 2 in the left column and a 5 in the right column, otherwise known as the frequency column. This would usually be where there are more than 20 values or participants, as the range of the values is no more than 20. After you've gone through each of these values and noted the frequency of them, you can then work out the cumulative frequency from this data. To do this, you focus on the frequencies. You go down the list of figures for frequency, adding each frequency to the previous one. Once you've done this for the whole list, you will be left with the cumulative frequency. You can see a working example of how this is achieved in the figures above. Figure 4 shows the raw data for thigh girth scores of the gymnasts. You can see then that this is put into rank order in Figure 5. Figure 6 is where cumulative frequency begins to take place. So you have each figure that is shown in the data on the left-hand side, and in the right-hand column you have the amount of times that has occurred. So 34 occurred once, for example, 45 occurred twice, 49 occurred 3 times. The highlighted cell, which is in orange, that shows the cumulative frequency. So you can see you're adding the previous one to the one that you're currently on. So 1, and then you're adding 1 is 2, plus another 1, and so on and so on and so on. And the cumulative frequency that is achieved here is 14. Again, this is generally used, simple frequency distribution is generally used with smaller groups of approximately 20, because once you start achieving higher numbers, the numbers become a lot more difficult to manage, as it's a lot to manually go through and add together. So the last one is grouped frequency distribution. So this is basically grouping the values and noting the frequency of those values in each group. So to do this, you need to decide on the interval size for each group. So this would mean, for example, you can see the example here, so that you've got standing vertical jump values in Figure 7. So those are all the scores that have been achieved. So to find the interval size, you find the range, and in this case the range is 41, and you divide that by 14 in this case, because that is the amount of scores we have, amount of participants we have, sorry. So 41 divided by 14 is 2.928, which is why you can see here I've used groups that are a range of 2, so 15 to 17 is 2, 18 to 20 is 2. It's easily established what size the groups need to be for the grouped frequency distribution in order to make it easier to read, easier to establish. So grouped frequency distribution is actually summed up pretty well just by looking at Figure 8. You can see that on the left column you have the groups that have been made, so 15 to 17, 18 to 20, 21 to 23. And then on the right hand side you have the frequency. So all this means is that in the groups 15 to 17, the scores that were achieved between 15 to 17, there were 3 scores that were between 15 to 17. There were 2 scores that were between 18 and 20, and so on. It's very similar to the previous one, which was simple frequency distribution. It's practically the same, however, you're not looking at each individual score that occurs. You're grouping it make it more refined, I suppose. It's especially important to use group frequency distribution if you have a larger sample size, because it means that there's less of an overload of numbers. For example, like you can see here, there's each individual number in simple frequency distribution. You could refine that down and reduce that to half the size and have a table half the size using group frequency distribution, which would make it a lot easier to read potentially. However, then you don't have the specifics of each individual score, which may be something that you need to think about in terms of data preparation before you go on to presenting your data.